Our place in the cosmos. When you step outside on a clear night and look at the stars, it's easy to forget that we live inside a vast system of celestial bodies bound together by gravity. This system, our solar system, is not only our home, but also our first and closest window into the mysteries of the universe. The solar system consists of the Sun, 8 planets, their moons, dwarf planets, asteroids, comets, meteoroids, and countless particles of dust and gas. All of these objects orbit the Sun, which contains 99.8% of the total mass of the system. In essence, everything we see, Earth, Mars, Jupiter, Pluto, the asteroid belt, are simply byproducts of the Sun's birth billions of years ago. The solar system is our cosmic neighborhood, and by studying it, we learn about planetary formation, the conditions that allow life, and even the possible fate of Earth itself. The story of our solar system begins about 4.6 billion years ago with a vast cloud of gas and dust called a solar nebula. This cloud collapsed under its own gravity, possibly triggered by a nearby supernova explosion. As it collapsed, it began to spin, flattening into a rotating disk. At the center of this disk, material clumped together to form the proto-sun. In the surrounding disk, smaller clumps of matter collided and merged, forming planetesimals, the building blocks of planets. Over millions of years, these planetesimals grew into the planets we know today. This process, known as the nebular hypothesis, explains why all the planets orbit in roughly the same plane and why they revolve in the same direction as the Sun's rotation. The Sun is not just the central star, it is the engine of the entire solar system. Without it, planets would drift away into the void structure of the Sun. The Sun is a massive sphere of hot plasma with several layers. Core, where nuclear fusion occurs, turning hydrogen into helium and releasing tremendous energy. Radiative zone, energy slowly moves outward by radiation. Convective zone, hot plasma rises and cooler plasma sinks, transporting energy. Photosphere, the visible surface of the Sun. Chromosphere and corona, outer layers, visible during solar eclipses. Every second, the Sun converts 600 million tons of hydrogen into helium, releasing energy equivalent to billions of nuclear bombs. This energy sustains life on Earth. The Sun is not static, it constantly changes. Solar wind, a stream of charged particles, flows from the Sun, shaping the heliosphere and protecting Earth from cosmic rays. Sunspots, dark, cooler regions linked to magnetic activity. Solar flares and coronal mass ejections, explosions that can disrupt satellites, power grids, and communication on Earth. Understanding the Sun is essential because it controls space weather and Earth's climate. The first four planets, Mercury, Venus, Earth, and Mars, are called the terrestrial planets because they are small, rocky, and dense. Mercury, the swift messenger, closest planet to the Sun. Extremely hot during the day for 130 degrees Celsius and freezing at night -180 degrees Celsius. No atmosphere to retain heat. Surface resembles the Moon, full of craters. Despite being small, Mercury's iron-rich core makes it surprisingly dense. Its weak magnetic field suggests it is geologically inactive today. Venus, Earth's twin gone wrong, similar size and structure to Earth. Covered in thick clouds of carbon dioxide and sulfuric acid. Surface temperature approximately 465 degrees Celsius, hot enough to melt lead. Atmosphere creates a runaway greenhouse effect, making it the hottest planet in the solar system. Venus teaches us the dangers of unchecked climate change, what can happen when a planet's atmosphere traps too much heat. Earth, the blue planet, the only known world with life. Atmosphere rich in nitrogen and oxygen, liquid water covers 70% of its surface. Plate tectonics recycle nutrients and regulate climate. Earth's magnetic field and moderate greenhouse effect make it uniquely habitable. So far, no other discovered planet matches its balance. Mars, the red planet, half the size of Earth with a thin CO atmosphere. Average temperature, -60 degrees Celsius. Surface features include the largest volcano Olympus Mons and deepest canyon Valles Marineris in the solar system. Evidence suggests liquid water once flowed, and possibly microbial life may have existed. Mars is a prime target for exploration, with future plans for human colonization. The outer planets, giants of the solar system. Beyond the asteroid belt lie the gas and ice giants Jupiter, Saturn, Uranus, and Neptune. These worlds are far larger than Earth, with thick atmospheres and dozens of moons. Jupiter, the king of planets, largest planet in the solar system, more than 1,300 Earths could fit inside. Composed mainly of hydrogen and helium, like a failed star. Famous for the Great Red Spot, a storm larger than Earth that has raged for centuries. Has faint rings and at least 95 moons of Jupiter. A most volcanically active body in the solar system. Europa, icy surface with a subsurface ocean. Prime candidate for extraterrestrial life. Ganymede, largest moon in the solar system, bigger than Mercury. Callisto, a heavily cratered, ancient surface. Jupiter's enormous gravity acts as a shield, deflecting comets and asteroids that might otherwise strike Earth. Saturn, the Lord of the Rings, second largest planet, known for its stunning ring system. Rings are made of ice and rock particles, some as small as grains of sand, others as large as mountains. Atmosphere shows beautiful bands and occasional giant storms. At least 146 moons discovered. Moons of Saturn. Titan, larger than Mercury, with thick nitrogen atmosphere and lakes of methane and ethane. Enceladus, icy moon with geysers shooting water into space, hinting at a subsurface ocean. Saturn, like Jupiter, is mostly hydrogen and helium with no solid surface. Uranus, the tilted planet, seventh planet, discovered in 1781 by William Herschel. Composed of hydrogen, helium, and ice's water. Methane, ammonia. Distinctive blue-green color due to methane in the atmosphere. Rotates on its side with a tilt of 98, possibly caused by a massive collision. Has faint rings and 27 known moons. Uranus's extreme tilt results in unusual seasons. Each pole experiences 42 years of continuous sunlight followed by 42 years of darkness. Neptune, the windy giant, eighth and farthest planet from the Sun. Deep blue color from methane in its atmosphere. Known for the fastest winds in the solar system, up to 2,100 kilometers per hour. At least 14 moons, with Triton being the most notable. Triton orbits Neptune in the opposite direction of the planet's rotation, suggesting it was captured from the Kuiper Belt. Has geysers that spew nitrogen, indicating internal activity. Voyager 2, in 1989, provided the only close-up images of Uranus and Neptune, and future missions are eagerly awaited. The moons of the solar system. Moons are not just passive companions. Many are worlds of their own. Our moon Earths stabilizes Earth's tilt and climate, influences tides, and may have played a role in life's development. Europa Jupiter likely has a salty ocean beneath its ice, prime candidate for alien life. Titan Saturn, thick atmosphere, rivers, and lakes of methane, resembles early Earth. Enceladus Saturn, water plumes detected containing organic molecules. Ganymede Jupiter has a magnetic field unique among moons. Triton Neptune, active geysers, possibly hiding a subsurface ocean. Moons may hold the key to answering one of humanity's biggest questions: are we alone? Asteroids and the asteroid belt. Between Mars and Jupiter lies the asteroid belt, a region filled with rocky remnants from the solar system's formation. Ceres, largest object in the belt, classified as a dwarf planet. Shows evidence of water ice beneath its surface. Vesta, second largest asteroid, with a massive impact crater revealing its interior. Other notable asteroids: Pallas, Hygiea, and many near-Earth asteroids that pose collision risks. Asteroids are scientifically valuable because they preserve the original material from which the solar system formed. Some even contain water and rare metals, making them targets for future space mining. Comets and the Kuiper Belt. Beyond Neptune lies the Kuiper Belt, a region filled with icy bodies. Pluto, once the 9th planet, now classified as a dwarf planet, has 5 moons, including Charon, almost half its size. Eris, Haumea, Makemake, other dwarf planets in the Kuiper Belt. Comets, icy objects that develop tails when they approach the Sun. Famous examples include Halley's Comet and Comet Hale-Bopp. Even farther away lies the hypothetical Oort cloud, a spherical shell of icy bodies thought to be the source of long-period comets. It represents the outer boundary of our solar system. The solar system's boundaries, though the solar system may seem limited to planets and moons, it actually extends much farther. Its true boundary is shaped by the Sun's influence. The heliosphere. The heliosphere is a bubble of charged particles, solar wind blown by the Sun into interstellar space. It acts as a shield, protecting planets from cosmic radiation. Termination shock, where solar wind slows abruptly as it meets interstellar gas. Heliosheath, region of turbulent interaction between solar wind and interstellar medium. Heliopause, the outer boundary, where the Sun's influence ends and interstellar space begins. Voyager 1 and Voyager 2 have crossed the heliopause, making them humanity's farthest messengers. The Oort cloud, far beyond the Kuiper Belt, the Oort cloud may extend up to a light year from the Sun. This vast sphere of icy bodies is thought to be the source of long-period comets. Though never directly observed, it represents the outermost frontier of the solar system. Exploration of the solar system. Humanity has always dreamed of exploring the heavens, and in the last century, we've made astonishing progress. Space probes Voyager 1 and 2, launched in 1977, they explored Jupiter, Saturn, Uranus, Neptune, and are now in interstellar space. Each carries the golden record, a time capsule of Earth's culture. Pioneer 10 and 11, first probes to travel beyond the outer planets. New Horizons flew past Pluto in 2015, revealing stunning details of its surface. Juno, currently orbiting Jupiter, studying its atmosphere and magnetic field. Cassini explored Saturn and its moons, discovering Enceladus's water plumes. Rovers and landers. Apollo missions landed humans on the Moon. Mars rovers Spirit, Opportunity, Curiosity, Perseverance exploring Martian geology and searching for signs of life. Insight, studying Mars's interior. Telescopes, Hubble Space Telescope provided breathtaking images of planets, galaxies, and nebulae. James Webb Space Telescope offers new insights into planetary atmospheres and the early universe. Space exploration has turned the solar system from abstract points of light into real, diverse worlds. The future of the solar system, the fate of the Sun. The Sun, like all stars, will not last forever. In about 5 billion years, it will exhaust its hydrogen fuel. It will expand into a red giant, engulfing Mercury and Venus and possibly Earth. Eventually, it will shed its outer layers, creating a glowing planetary nebula. The remnant core will shrink into a white dwarf, slowly cooling over billions of years. The planets that survive may orbit a dim white dwarf sun, and the solar system will become a ghost of its former self. Long-term evolution on even longer timescales. Planets may drift away due to gravitational interactions. The Oort cloud may be stripped by passing stars. Ultimately, the solar system will fade into interstellar space. Human future in the solar system. While the Sun's death is far in the future, humanity's future in the solar system may unfold much sooner. Moon colonies. NASA's Artemis program aims to establish permanent bases on the Moon. Mars colonization, SpaceX, and other agencies plan human missions to Mars within decades. Asteroid mining could provide metals and water for space industries. Terraforming ideas. Some scientists dream of making Mars habitable. By expanding into the solar system, humanity could ensure survival beyond Earth. Philosophical significance. Studying the solar system teaches us profound lessons. Fragility of Earth. Among all planets, only Earth supports life as we know it. Unity of nature. The same laws of physics govern the sun, planets, and distant galaxies. Human curiosity, our drive to explore, connects us to the universe itself. In many ways, the solar system is a cosmic classroom offering examples of planetary extremes, from Venus's heat to Europa's icy seas. The solar system as a model. Our solar system is more than just our home, it's a template for planetary systems everywhere. By studying it, we gain insight into planetary formation, the transition from dust clouds to full worlds. Atmospheric science, how atmospheres shape climates, Earth versus Venus versus Mars. Habitability, what conditions allow water and life to exist. When astronomers study exoplanets around distant stars, they compare them to the worlds we know here. The diversity within our own solar system helps us imagine what's possible elsewhere. Lessons from each planet. Mercury reminds us of the sun's power and the vulnerability of airless worlds. Venus warns of runaway greenhouse effects. Earth shows how delicate and rare habitability is. Mars suggests a once living world now frozen, holding clues to life's resilience. Jupiter demonstrates the scale and protective role of giant planets. Saturn teaches about beauty in planetary rings and diverse moons. Uranus offers insight into tilted axes and strange seasons. Neptune reveals the extremes of wind and weather. Pluto and Kuiper Belt remind us that planetary systems don't end neatly but fade into distant icy frontiers. Each world is like a chapter in a cosmic textbook. The unity of the solar system, though diverse, all solar system bodies are bound together by the sun's gravity. This unity reflects a cosmic harmony. Stars form, planets orbit, moons dance, and comets sweep across the sky. The solar system is not chaos, but a cosmic symphony where each object plays its role. This unity also highlights the fragility of balance. Slight changes in orbits, atmospheres, or the sun's energy could dramatically alter worlds. Humanity's expanding horizon. For thousands of years, humans saw the solar system only through myths and naked eyes. In the past few centuries, telescopes revealed planets as worlds. In the last 60 years, spacecraft turned points of light into detailed landscapes. Now, we stand at a new threshold. Robotic explorers roam Mars. Probes fly beyond the heliosphere. Plans for human colonization of the Moon and Mars are real. We are no longer mere observers, we are participants in the story of the solar system. The future beyond the solar system. While the solar system is vast, it's only the beginning. The nearest star, Proxima Centauri, lies 4.2 light-years away, tens of thousands of times farther than Pluto. Yet, with advancing technology, interstellar exploration may one day be possible. Still, before venturing outward, the solar system itself offers lifetimes of exploration. Thousands of moons, asteroids, and comets remain unvisited. Oceans under Europa and Enceladus could harbor alien life. The mysteries of Uranus and Neptune await new missions. Spiritual and philosophical reflections. The solar system is not just science, it is also inspiration. Cultural meaning. Every civilization has looked up at the planets and woven them into stories. Perspective. From space, Earth is a tiny blue dot, fragile yet vibrant. Responsibility. As stewards of Earth, we must protect it while expanding wisely into space. The solar system teaches humility. It shows us how small we are, yet also how far our curiosity can reach. Final thoughts. The solar system is a masterpiece of nature, a star surrounded by a family of worlds, each unique, each telling part of the cosmic story. It is our birthplace, our laboratory, and our future frontier. It challenges us to look beyond the familiar, to explore, to wonder, and most importantly, it reminds us that life, as we know it, is precious and rare. When we gaze at Saturn's rings, Mars's red deserts, or Jupiter's storms, we are not just looking at distant worlds, we are looking at the story of creation itself. And one day, perhaps, humanity will spread across these worlds, carrying the light of Earth into the darkness of space. From the blazing heart of the sun to the icy edges of the Kuiper Belt, our solar system is more than just a collection of planets and moons. It is a living story of birth, destruction, beauty, and endless mystery. Each world tells us something profound. Mercury whispers of the sun's power. Venus warns of greenhouse fire. Earth sings with the miracle of life. Mars teases us with the memory of flowing rivers. Jupiter, with its colossal storms, stands as a guardian. Saturn wears rings of icy poetry. Uranus tilts in defiance, while Neptune howls with the strongest whines. And beyond, Pluto and the frozen wanderers remind us that our system has no true boundary. It fades into the vast ocean of the stars. We, the children of Earth, are bound to this solar family. But unlike the planets, we can choose our path. With rovers on Mars, probes beyond the heliosphere, and dreams of colonies among the stars, humanity is no longer confined to one world. The solar system teaches us a humbling truth that we are small, fragile, and temporary. But it also gives us hope that curiosity can carry us farther than gravity ever could. So, when you look up at the night sky, remember, those points of light are not just distant stars. They are destinations, challenges, and promises. And our journey across the grand theater of the cosmos has only just begun. This is the story of our solar system, and we are only at the first chapter. So stay tuned for more updates and hit that subscribe button and always look up.